So I will present about the introduction slide. Malayan Flour Mill Berhad MFM is one of the leading flour milling companies in Malaysia with over 50 years of experience. It was established as the first flour mill in Malaysia and produced high quality flour using imported wheat from countries such as Canada, Australia, the USA and Eastern Europe. MFM also operates flour mills in northern and southern Vietnam and processing over 500,000 tons of wheat annually. For our industry visit, MFM was chosen because it uses advanced machinery and large-scale electrical system in its production process. The visit helped us understand industrial, electrical, machine, energy management and maintenance practice. The knowledge gained is useful for understand how efficient energy system can improve industrial operation.
Hi, I'm Nurul Natasha Binti Zaidi. So today I will explain about the company background. Malayan Flour Mill Berhad or MFM is a Malaysian food manufacturing company established in 1961 and is one of the pioneers in the country flour milling industry. The Pasir Gudang Flour Mill is strategically located near Johor Port that providing efficient access for importing raw wheat and distributing finished flour product to both local and international markets. The plant operates as a high-capacity continuous production system. Wheat is imported from Canada, Australia, the United States and Europe to ensure consistent flour quality. The flour produced is widely used in bakery, biscuit, noodle, pastry and other food processing industry. The production process begins with intake and storage, followed by cleaning to remove impurities such as dust, stone and metal. The wheat is then conditioned to achieve the required moisture content before entering the roller mill for grinding. The flour is separated using plant shifter, further refined by purifier machine, transported through a pneumatic conveyor system, stored in silos, and finally filled manual by operators while automatic machine perform the sealing and tapping process. From an electrical engineering perspective, the plant relies on AC induction motor to drive equipment such as roller mills, conveyors, shifter and fan. Variable frequency drives are used to control motor speed and improve energy efficiency, while soft started and start data started protect the motor during startup. The entire production process is automatic using PLC system and monitored through SCADA, ensuring efficient, reliable and continuous flour production.
This is the electrical machines application. So the first one is step-down transformer. The facility uses 5 transformer units to step down the 22 kV high voltage from TMB down to a safe 415 volt low voltage. This step-down power is then distributed to the motor control center. So the second one is AC induction motors. These are the main workhorses of the plant. For example, motor 1 drives the main conveyor belt and motor 2 powers the floor flattener. The job is to convert electrical energy into the heavy mechanical torque needed to crush and move the flour. So the third one is motor control center or MCC. This panel houses all the protection and control gear, specifically the star delta starters, MCBs and overload relays. The star configuration gives the motor a quick start, while the delta configures ensures smooth continuous running to prevent massive inrush currents. So lastly, we have inverters or variable frequency drives. While standard motors run at a fixed speed, inverters are used for large machines like that main belt motor we just mentioned that allow operators to precisely adjust motor speed to match the exact load required, which greatly improves the efficiency. Together, these 4 systems manage the power flow and ensures the mill operates smoothly.
My name is Arati Shakira and I'm going to continue to talk about the problems or issues related to the electrical machines. The first one is transformer overheat, which occurs during peak production and causes the transformer to overheat as well as create some buzzing noises. And this can cause multiple problems such as insulation breakdown as well as voltage sag. The second is motor tripping and broken chains. And because motors suffer from mechanical overload, the driving chains can snap and the overload relay can trip. And one of the rules that occurs in the Malayan flour mill is the 3-trip rule, where if it occurs more than 3 trips, then they have to do a regular maintenance of the system. The third is bearing stress and misalignments, where motor bearings at the end of drive and suffer from high amounts of strain, which causes overheating, disrupting the physical alignments of the bearings towards the shaft. The fourth is severe electrical faults due to unbalanced winding resistance. This is caused by failure from copper windings, causing a short circuit, and motor failure can occur because of this. The fifth and final one is explosion hazard, which can occur specifically in MCC or motor control systems. This is occurred because of the switching of starter and contactors. So for the proposed suggestion for those 5 points, for the transformer heat, first is because there's already natural air circulation in the gated room, possible solutions is to install automatic controlled exhaust fans which turn on during a specific temperature threshold to suck out the heat. The second is motor tripping and broken chains, and current solutions for this is to install inverters or soft starters on belt motors to prevent starting currents to damage the motor. The third is bearing stress and misalignment, and one of the ways to overcome this is predictive maintenance. So this allows the detection of misalignment before failure. One of the ways is to install temperature thermal sensors in the locations of the bearings. The fourth is severe electrical faults, and one of the ways to overcome this is to do a routine test during the plant's downtime to test the installation resistance. The fifth and final solution and proposed suggestion for improvement is to ensure that the MCC sensors that house the contactors as well as the starters is enclosed in explosion-proof boxes to prevent the explosion affecting the outer area of the room.
So I will present about discussion. One common issue is transformer overheating, which is caused by high operating temperature and poor ventilation. This can damage the insulation and shorten the transformer lifespan. To overcome this problem, exhaust fan and improved cooling system can be installed. The second is motor tripping and broken chains due to overload condition and high starting current. This problem can interrupt production and damage equipment. The use of soft starter and inverter can help reduce this issue by controlling the starting current. Lastly, bearing stress and misalignment are usually caused by excessive vibration and improper shaft alignment. This condition can lead to overheating and bearing wear. Predictive maintenance and thermal sensor can be used to detect problems early and prevent serious damage. Lastly, the conclusion. In conclusion, the industrial visit to Malayan Flour Mill Berhad MFM provide valuable exposure to the operation and maintenance of electrical machines in a real industrial environment. Several issues were identified include transformer overheating, motor tripping, bearing misalignment, electrical fault, and explosion hazard. The proposed improvements such as better cooling system, predictive maintenance, routine testing, and enhanced safety measures can improve equipment reliability. Overall, the visit enhanced our understanding of industrial electrical system and the importance of proper maintenance practice.